time for questions.
Reporter and the opponent, please.
Good morning, I'm Joan. I'm going to make the review of problem 14. For the reporter, you use the linear fit for your graph.
Yes.
Do you truly believe that it's a linear fit, that graph?
Well,
please,
it is
can
possible.
you be quick for?
It is possible that our data are wrong, but I think, well, it fits. So that's why I fitted it with.
Okay.
It has a good fit.
Okay.
At least in mine.
So what are the forces acting while the ball is in the sand?
Well, the gravity of the ball and the pressure the sand exerts on the ball, or on what do you mean?
The force is acting the steel ball.
On the ball.
Yes.
So the gravity, the gravitational acceleration of the Earth, then the sand exerts a pressure on this ball, and since the ball is moving downwards, the sand exerts an upward force and slows the fall of the ball.
The opponent agrees with that.
Opponent.
Do you agree with that?
Pardon, sorry. sorry. Can you repeat the
The force is acting the system.
The force
Do you
acting
agree
on the ball?
what the relator? The forking. Okay. I'm gonna change the questions because we don't have much time. How do you think the velocity of entrance of the ball in the sand associated with the hydrostatic pressure influence in the point of collapse of for the formation of the jet?
Well, you mean, well, if we have the ball of a big higher velocity, it falls down faster, and the point of where it forms the first jet is lower, because the hydrostatic pressure increases as the jet grows bigger and it goes faster.
Okay. For you, is there any critical depth for this collapsing? Yes or no?
Well, probably there would be a critical depth for this.
Yes.
Yes.
And what defines this critical depth?
There has to be it has to be at least some depth beneath the surface for the pinch to create, actually. Because if you only throw it and it creates like a 1 millimeter also.
Do you agree with that?
About the force on the ball, I think that
this last one. Do you agree?
The critical, I think
Okay.
Yeah, there must be some critical.
Do you think that the humidity of the sand is important for the phenomenon? It could influence this?
Of course it is important for the phenomenon, since you can't observe it in, we couldn't observe it in sand, but we managed to do it in soda. Thank you, soda.
Okay, time's up.
Good morning, I'm João, and I'm going to make the review of problem number 14, Granular splash. First, summary of the presentation. They present a qualitative explanation. In the experiment, they changed the height of lens, the different spheres, and the granular material, the changing of this granular material. And the conclusion, they conclude only about the experimental data, with no clear conclusion between the experiment and the theory. Some positive and negative points of the reporter. They have a qualitative explanation of the phenomenon that was really good with some pictures. They mention the air existence condition for the sequence of events. They have a variation of the lunch of height, even though we don't have a good fit. As you can see, we have different fit, a linear fit that's not really applicable for us. They change the material and they consider this fluidization of the sand. Some negative points, they disconsider the humidification of the sand, and the problem says about dry sand, so it could be important to analyze what is dry, what is not dry, and what are these conditions to happen the effect. They did not mention the dissipative force, even when we asked about them, when we have the friction forces acting in function of this distance, and this direct force that that's influenced by the velocity of the sphere in the material. They didn't investigate the motion inside the sand, don't analyzing the forces acting the ball. The consequence of the inner jet that they mentioned, they don't discuss about that, don't talk about that. The splash is not studied, only the jet formation and all the properties of the jet. They have a linear fit, as I mentioned in the graph, where you have influence of many parameters like the velocity that change the direct forces and the size of the grains and the regularity of them that change this, that doesn't make this be a linear fit. The position in which the ball collides, as you could see in the video, sometimes in the center of the recipient, sometimes is in the head of the recipient. That could change, could affect. The velocity of entrance is not analyzed, and we don't have a quantitative analysis of the phenomenon with any equation or some relations between the parameters to be analyzed, even theoretically as experimentally, and we don't have this clear comparison between the theory and the experiment. About the opponent, they note the lack of some parameters evaluation as the size of the grains, the regularity, the compression of the sand. They noted the linear fit that was really good, and noted that they didn't have an explanation of the splash. The negative points, they didn't mention the humidity, the dissipative forces, the friction between the grains, the size, the velocity of entrance is not mentioned for them. The size of spheres, the relation between them, they analyze it, but they don't have this comparison theoretically. And the critical depth is not questioned. About the discussion, the discussion about the splash, the questions about the motion of the particles, and the sequence of events was to question, was really good. But the discussion does not lead the audience to a conclusion about some of the main parameters that were mentioned. And the opponent gives his opinion about what, they didn't make clear what they want to do and what were their opinion. So that's it, and thank you for your attention.
Thank you. Reporter, your concluding remark?